Let us look at how to draw a line whose length is the fourth root of 2. So based on that same logic, we will be able to arrive at a line whose length is fourth root of 3, 4, 5, and so on. So let's start with a point A. Let's draw a line AB whose length is 1. And now we draw a perpendicular from B, perpendicular to AB. Let's call it as BC, which is also of unit length. Now, previously we have seen that AC is going to be root 2. We take this AC and we draw a line of equal length. So let's take a point B and draw a line equal to AC, and let's mark this endpoint as E. To this DE, we add another line segment equal to unit 1. So DE is root 2 and EF is 1. And now we basically figure out the mean proportional between DE and EF. And we know how to do that. Again, we have seen this. We draw a semicircle on DF and we draw a line perpendicular to DF at E. So let this be H. So now EH is going to be root 2. That is the fourth root of 2. This can be written as DE is to EH is equal to EH is to EF, which basically implies that EH is equal to square root of DE times EF. And if you substitute this, we get square root of DE, that is root 2 times 1. So root 2 we will get. And what Euclid says is he calls this EH as a medial line. So any line of length rho times root k, where rho is a rational number and root k cannot be simplified, is called median. In the above example, in case of EH, rho is equal to 1 and k is equal to 2. And the way Euclid describes all this is he says AB is commensurable in length with BC. AB and BC are incommensurable in length with AC. AB and BC are commensurable in square only with AC. That means if you take the squares, they are commensurable. So AB square and BC square are commensurable with AC square, because AB square is 1, BC square is 1, and AC square is 2. When he says AC square, he is not talking, remember, algebraic. He is talking geometrically by actually drawing a square on AC and drawing a square on AB and drawing a square on BC. Okay, now coming to this side, EH is incommensurable in length with AC. Remember, AC is equal to DE. So EH is incommensurable in length with AC or DE and EF. EH is incommensurable in square with AC and EF. Because if you take the square of EH square is going to be root 2. And root 2 square is 2. And 1 square is 1. So root 2 is incommensurable with 2 and it is incommensurable with 1. So basically again he is drawing squares on that. So that's how his language is, because when he was writing the elements in his time, these notations were not there for square root. And this he describes it in his proposition number 21 of book 10. And by the way, rho times root k is also written as rho times k to the power of 1 by 4. So you have seen how we can draw a line segment EH whose length is root k, or specifically speaking, root 2. That is fourth root of 2. If we want to arrive at root 3, what do? Again, previously we have seen how to arrive at a line segment whose length is root 3. So that we copy it here, we add 1 to it. So again, when we take the mean proportional, we will end up with root 3. Interesting, right? That's it for now.